Hi there. Welcome to my session on SQL Server networking and security. My name is John Martin and I will be taking you through the session. Now, just to say, the session is recorded today, so I am actually going to be able to respond to you in the chat, so feel free to ask questions and I'll get back to you as soon as I can as we go throughout this. So let's get on with the session. So, as I said, my name is John Martin. I'm Principal Consultant at JQM Consulting. My Twitter and LinkedIn are there. Please feel free to connect with me. I've been working as a Microsoft Data Platform Engineer in one form or another for well over a decade now, and I'm a Data Platform MVP and Chartered IT Professional with the British Computing Society. It's enough about me. On to what we're going to be talking about today. So, what are we thinking? Network security, SQL Server. Typically there's some configurations that people will always look to start off with, and it's all about understanding how appropriate these are, whether or not we should be looking at doing something different. But first and foremost, the key things we're going to cover are really not using the default port for SQL Server. Something that I see in many environments with my customers that I've worked with over the years, and it's an interesting one. We'll come back to that in a moment. The other option that we're looking at is ticking a little box that says hide SQL Server instance. Now, both of these are additive and can help secure your SQL Server environment and your networking systems. But as with anything, it depends as to how appropriate they are and how effective they're going to be. So we start thinking about not using the ports that aren't the default port for SQL Server. In many scenarios and many customers I've worked with, I've seen them basically take 1433 and I've seen them switch it to say something like 5200 or 6800, things like that, and then using that across the entire network. If you do something like that, what it means is you're essentially just changing what becomes the default port for SQL Server in your organization, and if it's the same port on every single SQL Server, then it kind of defeats the object of moving away from 1433, because it's very easy to discover that information, whether it's through packet sniffing, whether it's through just doing network discovery, that type of thing, which is where then the hide SQL Server instance comes in. In and itself can be very useful, stops enumeration attacks and things like that. But the big thing that it depends on here is really you need to start looking at your naming conventions. Because you may hide the SQL Server instance, but if your server naming convention gives away what that system is, then it's not really having much in the way of added benefits, unless it's a completely automated type of attack you're trying to sort of prevent against, where they're doing enumeration and network walking, that type of thing. Because if your servers are called SQL 01, DB05, things like that, it does give away what the system is. So again, ticking that box and hiding the SQL Server instance is only so good as the things that you put around it. If you're going to rely on these two sort of items alone for protecting your SQL Server environment on the network, then the reality is you're probably better off not doing it, in all honesty. For the complexity that it adds to your environment, the benefit that you're going to see by doing these two things only is going to be very low. Okay. What I'd say in around the non-default ports for SQL Server is, if you're going to go down a non-default port, then you need to have a unique port for every single instance in your organization, in your network environment. Because that way, if someone compromises or discovers information about one server, that doesn't then automatically sort of imply what the ports are going to be on another server. If you switch over to using things like dynamic ports for everything and you turn browser on, again, you're kind of defeating the purpose of what you're doing if you're doing it for security perspective. So, whilst they are very useful in and themselves, in isolation like that, not great. Okay, so if we're not going to use those, or I'm sort of saying that they're not the best thing in the world to be looking at, what? Okay. The first thing really that comes down to it is segmentation of your network. Okay. This is really key. What you're looking to do here essentially is break your network up into distinct subnets and then limiting access for communications between those network segments. Okay. There is another concept called microsegmentation, and we're going to cover both of those as we go through the session today. But when you're architecting your deployments and your infrastructure, you need to engage with the networking team and the server team, because only when you collaborate and come together will you end up in a situation where you're going to be in a more secure scenario. Okay. And then the other option is obviously encrypting traffic when it's on the network. If it's moving, then it can be intercepted. If it's running in the clear, then that's where your problem's going to be. And we're going to talk about a couple of the options you have for encrypting traffic between your applications, between your servers, things like that. Okay, so these are the two key principles we need to think about. But before we get into the detail of that, there's some important things we need to understand. And the first of all is the mindset that we need to adopt. Okay. First and foremost, the key thing to understand here is really that it's a case of when, not if. Okay, there's going to be a breach, there's going to be a security issue, there's going to be a security incident. In that scenario, what does that mean? Okay, well, first and foremost, if you've accepted that it's going to happen, when it does finally happen, it's less of a surprise, you're more prepared for it. Okay, this is the type of thing where you're going to accept that it's going to happen. So what you do to offset that is you start planning. Okay, have run books in the event of a data breach, in the event of a ransomware attack, in the event of various different things. Have those scenarios documented, because there's only really sort of 4, maybe 5 key scenarios you need to understand, and how you then respond, because a lot of them will be very, very similar to everything you're likely to encounter. And when you've got that mindset, you're prepared for it, it means you can respond better. Okay. What it also means is that when you come to design and implement new data platform solutions, whether they're on premises, whether they're in the cloud, whether they're hybrid scenarios, it puts you into a better mindset for thinking about how can I build this in a secure way. Secure by design, that's the key thing to understand here. Okay, there's 2 schools of thoughts that I've experienced. There's security first, and then there's secure by design. Security first doesn't work. Okay, security first, typically where you put security at the forefront of everything you do, and it must be secure, has detrimental and negative impact to things like user experience, to performance, to system stability, to operational efficiency, because that focus is all about making it 100% secure. In that sort of scenario, you end up inherently with less secure systems, because it's difficult for people to work with, and they will actively try to circumvent that. They will try to work around those controls. Whereas if you adopt a secure by design mindset, you're very much requirements driven. What do we need to deliver, and how do we do that in a secure way? So you're taking on board the requirements, you're understanding what the user experience needs to be, you're understanding what the functional and non-functional requirements are, and then you look at overlaying that with security, and that's when you start thinking, okay, how do we achieve this? But what are the risks that we're trying to mitigate? How many of them can we eliminate? How many of them do we need to look at accepting? And finding that balance. It's about taking a systems-based approach. Okay, when you start thinking about performance tuning your environments, or tuning a car, or anything like that, you can tune the components in isolation, but that means that you end up moving bottlenecks around, and you also then potentially adversely impacting various other areas of the overall system. Whereas if you take a systems-based approach and look at bringing the whole thing up, and you may tweak something so it's more efficient, you actually may bring something down so it's slightly less efficient, but what it means is you end up with an overall system that is greater than the sum of its parts. Okay, so that's the sort of mindset you want to adopt. And then leading on from that, for that sort of secure by design, a very good design principle to start looking at is the whole zero trust mindset. So this essentially is where you're saying, we do not trust this, we do not trust network traffic, we assuming that there's someone, a bad actor potentially within our networking environment. We've got all of these things that you want to understand. Okay, well, how do we build a solution that is secure but at the same time meets the needs of the business? And in that sort of situation, what you're looking at is turning around and saying, okay, well, I'll be very explicit in what I trust. Okay, I'm going to trust that machine, so App Server 1 and SQL Server 2, they communicate because the application needs to talk to a database on that one. But I'm going to do it in such a way that I'm only trusting the traffic to the SQL Server instance on the specific port from that system is going to be trusted. Everything else that tries to come in from that server, so things like RDP traffic, SMB traffic, things like that. If they're not required as part of the system, I don't trust them, they shouldn't be coming in. And you start building those sort of boundaries and those sort of micro bubbles around your environment, and that way nothing can get into it, or you're restricting what you can get into it, you're restricting what leaves it, and you're basically saying, okay, well, I don't trust that. My first view is I do not trust this system unless I've explicitly allowed something. Never really take the approach where you're looking at implicit permissions. Okay, I'm implicitly trusting something, because in that scenario, that's when things become too permissive. That's when things can cause you a problem. Okay, there's a link there on the slide as well to Microsoft's Zero Trust sort of microsite. It's really, really good. Help you get in the right sort of state of mind, understand what Zero Trust is, and potentially how to look at going about implementing it. So, we've spoken about the mindset. Let's move on and start talking about network segmentation and what it is and why it's important. Okay. So when we start thinking about what we have in our business environments and our network environments, we've got our database systems. We then have our client devices, our end user compute, so printers, laptops, desktops, things like that out and about on the desks that may be in offices, or VPN users who are working from home. We've got our application servers, batch servers, web servers, things like that. And essentially when we start thinking about network segmentation, what we're doing is we're just creating boundaries around each of these areas of your business, essentially. Okay. And then we start thinking, okay, well, we've actually got our end users way out there, potentially out in the VPN world, that may be working from home or working on remote sites. You may have third parties that you're working with. And essentially what it means is when we start thinking about network segmentation, we break these down into distinct subnets. So 192.168.0 over there for our database systems, 192.168.1 for our end user compute devices, 192.168.2 for our application systems, and 192.168.3 for our external users. And by putting these boundaries in place and clearly defining them as network segments and using them only for these purposes, what it means is that we can actually put infrastructure firewalls in place and we can start restricting that traffic between them. Okay. Now, I have worked with some customers where we've seen very flat network hierarchies. Okay, very, very wide network segments used for application servers and just servers in general, infrastructure servers, so domain controllers, DNS servers, database servers, app servers, web servers. Yeah, it's a form of segmentation. I mean, so long as you've got your end user compute distinct from your back-end servers, you're starting off in a good place. But breaking it down into this segmentation means that in the event if someone compromises a web server, you've got a lot more control over what it can get to. Okay, by going through that infrastructure firewall, you're then starting to create these policies and these rules that will limit what you're looking at and saying, okay, well, what can these servers get to? How does it work for me? Where should we be going with this? Now, we start thinking about the rules we put in place. You may want to say, okay, well, these application servers here can speak to this database server here. So we're not actually then turning around and saying, well, we're going to let the entire network segment speak to each other. We're going to have the firewall in the middle there, and it says, okay, well, these hosts, when they communicate from this network segment to that network segment, those are the only ones that are allowed in on this particular protocol, on this particular port. So your distinct source and destinations. What it does mean is you do need to be looking at using IP addresses that are reliable. So you're looking at things like either DHCP reservations or you're using static IP addresses, because that way the firewall will always be able to work on that. There are some that are more intelligent that can use identity-driven access and things like that. But again, you end up with issues potentially when you're looking at compute machine accounts, anonymous authentication, things like that. Working back on this type of thing gives us a much stronger position. Now we start thinking, okay, app servers, database server, but what happens when we start thinking about, well, this end user compute device needs to run this application? So you can see there the end user compute device can talk to the application server, but it doesn't speak to the database server because it may not need to. Even if you're using things like pass-through authentication on a website, for example, within a corporate environment, we're using Active Directory or something like that, you're authenticating against that website. You don't need direct access potentially to the database systems. What you then say is, okay, well, this application server can then speak to those database systems, and that way your users still have access via the application to the database systems. what that makes is that means that we're a lot more secure, because typically what you're seeing in the end user computer space is that you're running DHCP. What that means is that the same device may not necessarily have the same IP address for its entire life. What that means is if you did need to grant direct access to the database servers, for example, what that means is you essentially got to open up that entire network segment for your end user compute devices, your laptops, your desktops, your printers, to be able to communicate with those target SQL servers. That's not a great scenario, because then that opens up the potential scope for where the network traffic can come from. And if there is a flaw or a vulnerability in the configuration, you're letting a lot more things in than you absolutely have to. This comes back to what I said earlier about being very explicit in what you're configuring. Okay, so if you want to be very explicit, say that these machines can speak to these machines, you don't say this entire subnet can speak to this machine, because then you start, as you get more and more users potentially within that space that need to speak to different servers, you end up then having a lot of network traffic being able to hit a lot of those database servers. Okay, if you do need to give people direct access with Azure Data Studio, Management Studio, those sorts of tools, your best bet is to look at implementing something like, say, Citrix or Windows Virtual Desktop or something like that, where you've got more control over where those network segments are and what those devices are that are going to be connecting things. So again, you're treating that application delivery as a back-end service for your users, and that's how you make it, again, a bit more secure. So the network segmentation that we've spoken about here is very, very good when we're going between subnets. Okay, where it falls down is if we're talking about traffic that happens to go between systems within the same network segment. Okay, in this sort of situation, what we're talking about here is, okay, so I may, for whatever reason, I need to remote desktop onto a particular server for whatever reason. Okay, I can then use that as a jumping off point to move laterally within that network segment from server 1 to server 2 to server 3 to server 4. Okay. The reality of it is, even as DBAs, we should be using sort of secure access workstations or privileged access workstations, whichever terminology you want to use, which means that management workstation can connect to those database servers for RDP, for T-SQL access, for Windows RM with PowerShell remoting, things like that. But what it means is that those servers really shouldn't be able to speak to one another, because they're not part of the same system necessarily. Where they are, yes, they need to be able to speak to one another, and you need to set up the rules and be very explicit so that server A can sort of talk to server B, for example, but not to server C and D. Okay. Now, what this term is, we take from what we talked about so far is network segmentation. What we now talk about is network micro-segmentation, and this is where we actually then increase the boundaries, and we actually put a boundary around every server. So what we're looking to do here essentially is limit access between those servers only where it's absolutely necessary. Now, why do we want to do this? The key objective that we're looking to do here is preventing what's referred to as lateral movement. And this is the ability where I say is that you can get onto one system and then you can move laterally within that network segment from one server to another without it going through firewall checks, because those infrastructure firewalls only really sort of manage traffic or track traffic between the network segments, not when they're out in layer 2 switching and actually going within those network boundaries themselves. Okay. Now, this lateral movement essentially is how things like ransomware, for example, can get into a system and get into a network and then spread out so rapidly if you've not got the controls in place to prevent that lateral movement, because many of the attackers and many of these automated systems will use our own management tools against us, things like PowerShell remoting and PSExec and things like that, to be able to go through. They'll enumerate systems, they'll look for compromised usernames and passwords, all of that sort of stuff, weak passwords. Very, very easy to find the hashes for accounts in Active Directory, compare them against a known list of hashes to find weak passwords, for example. If that password's breached and you've got RDP traffic from one server to another, then it becomes very easy to laterally move. Whereas if you've got controls in place, it becomes a lot more difficult. What this also means that we can look at doing is essentially workload groups. Okay, so as we spoke about earlier, is that those application servers speaking to the target database servers is if, for example, you then need to say, well, these are members of an availability group or a failover cluster, then those servers themselves can talk to one another very, very quickly, very, very easily. Okay, whereas they shouldn't be able to speak to anything else. And it's all about saying, okay, well, these only need to speak to each other, so those are the rules we're going to put in place, and we're going to say that they only speak on certain protocols, on certain ports, and that's what we're looking to do. Okay, so how do we achieve this? So at the most fundamental level, this is where Windows Firewall or things like IP tables, the operating system level firewalls that you can implement come into their own. Okay, now everyone's sort of given Microsoft Windows Firewall a bad rap over the years. The reality is it's actually a very, very capable piece of the operating system that has a huge amount of benefit that will help us secure our environments, especially when it comes to preventing lateral movement. Where it has fallen down historically is ease of management. Okay, that's something that's really been a big problem for it, and that's what many people still sort of think of now. But with things like PowerShell, it's become a lot easier to do remote management and management at scale for many servers, which means it's a very, very viable solution now, very, very low cost as well, to be able to implement it. Then you've also got various third-party solutions. So this is where things like if you're running a virtualized environment on top of, say, VMware, this is where you can use their NSX product. That allows you to start going into the virtualization platform and saying, well, in this scenario, these systems are allowed to talk to these systems. You take it out of the operating system and put it into the core infrastructure of the virtualization layer. Okay, can be a lot more complex. It does blur the lines between networking team and server team and virtualization team, because who becomes responsible for it, because the network configuration and the NSX configuration is embedded within the virtualization technology. So it can add some complexity when you start looking at merging that, but that, when you think about where we're going as an industry and the things that we're looking to try and achieve now, where people moving into roles like site reliability engineer and what have you, we're coming a lot closer together and we're collaborating a lot more as DevOps and agility takes forth. There are also third-party products like Illumio, and there's many others out there as well which will allow you to look at doing this. Many of the firewall providers have an identity access mechanism baked in which will integrate with things like Active Directory, which means you can then start limiting, okay, well, only these specific user accounts can access these target SQL servers, which, when you come back to what I said earlier about trying to limit end-user compute access into some systems, that's really where you can look to try and add that extra benefit, that extra capability. Okay, now when you start thinking about Windows Firewall, there's a couple of options for us around managing that at scale. Windows PowerShell, is one of the best ways to look at doing this. Again, we can script everything, we can make it parameter driven, and we just pass in variables and what have you, and that works a treat. PowerShell Desired State Configuration, or DSC as it's otherwise known, is another option as well, where you're very, very explicitly defining what those rules are, and then you're actually either pushing them or having the servers pull that information down to them. Okay, so there's a lot of options when we start thinking about the micro-segmentation capability. But at its core concept, it's all about making sure that if one of your servers in a network segment becomes compromised, that you're in a situation where you can be confident that the route from that server to the other systems within that network segment is very limited. Because in that scenario, that's where you end up being compromised the most. And you look at what happened to Maersk and various other ransomware victims. I mean, Maersk were taken almost entirely offline and had to go back to using paper and pencil for a lot of their systems. When you think about the type of thing they were shipping worldwide, that becomes very, very onerous, and it's amazing they're still in business. It's just a testament to the capabilities of their IT support teams that actually kept them running, got them back up and running again. Okay, so we've spoken about the mindset, we've spoken about a couple of the concepts for segmenting the networks, for micro-segmentation and network segmentation. So what we're going to do now is we've got a demo. So in this demo, we're going to talk through and I'm going to show you how to use PowerShell commandlets, which are built into Windows, to be able to manage the Windows Firewall on remote machines, essentially helping us set up that micro-segmentation, if you will. And then we'll look at doing exactly the same thing, but with PowerShell DSC, so you can see just how powerful that can be in the way that we can do this. So with that, let's start our demo. So here we are with the first demo. If we just open up ISE, we're going to do this demo in two parts. First half, we're going to quickly look at the built-in firewall commandlets that come with Windows to allow us to manage firewall rules on a remote system, and then we'll have a quick look at PowerShell desired state configuration, just to give you some idea of the art of the possible when it comes to managing things at scale with configurations. Now, the firewall rule and firewall profile commandlets, in fact all the commandlets that ship with Windows, are able to interact with remote systems using the sim session. So what I'm going to do here is I'm going to target my SQL 01 server, and if we start by having a quick look at the profiles at present, we've got the 3 default profiles: domain, private, public. Now, I would strongly recommend that all 3 of these are enabled, and that I'm making an assumption here that you're working in a corporate environment where you've got domain network traffic, where if you're not using the private or the public network types, have them enabled but have default denies in place. And what that means is if someone adds a network interface card and puts it onto the wrong virtual network, for example in a VMware or Hyper-V environment, what that means is that you're not likely to get traffic coming in on that, which again gives us that layer of security that we're after. Likewise, if someone plugs a cable into the wrong interface card from the wrong network segment when they're in a data center and physical environment, again, you're protected. And it's just about having that, well, what if sort of scenario. Well, what can go wrong? Well, people make mistakes, plug things in the wrong places, been there, done it, it's how I've learned. So this is just an added layer of protection. Make sure they're all on. Make sure your default denies on the ones you're not using, and that way you don't have to think about it. It makes life a little bit easier. Now, if we also look at the rules that ship with Windows out of the box, we'll see here that, yep, there's loads of them there. So we can see there's a huge number of them, covering a whole raft of different areas. So we want to create our own. Before we really dive in and start looking at it, there's some key information we want to think about. Where is the traffic coming from? What am I listening for that traffic on? Which IP address? On which protocol, on which port. Okay, and then comes back to what I said about the profile. Which profile are we going to apply this rule to? Okay, once we've got that core information, that's essentially the main body of our rule that we're going to be creating, then we can come down and we can start specifying that. Now, what I'm using here is a technique called splatting, and it essentially allows me to create a hash table of all of the parameter values I need for my commandlet. You'll notice here we're just giving name, a friendly name, a little bit of description, that way someone comes along behind us and they know what it's doing. One thing that is very important is give it a group. Okay, now this is not predefined, you don't have a set number that you've got to do, you don't have to go and create a group first, you just specify a string here, and it will mean that all of those rules that you create will have that. Now, when you start thinking about running multiple instances on a server, or potentially you're running availability groups, and you may have multiple availability groups on an instance on a server, and therefore potentially you're going to be looking at multiple listeners. Again, you may want to start grouping those rules up and say, okay, well, we've got a set of rules for listener 1, or a set of rules for listener 2. Likewise, if you're using failover cluster instances and you've got multiple FCIs in play, then again, this is a set of rules for this one, because you may be listening on a distinct IP address for that traffic, and you don't want anything that's coming directly to the servers potentially to get onto an FCI, stuff like that. Okay, so group them together, create it in such a way that it is standard, so that you can easily discern what they are. And what that means is, as we'll see later on, it becomes a lot easier when we start using some of the management commands. Obviously, we're allowing this traffic in because that's what we want. It's coming on the domain profile, and it's coming from this source on TCP/IP. We're using 1433. Now, one of the big things that we can do with Windows Firewall as well is we can actually bind these rules to a Windows service. So what that means is if the service is not running, the traffic's not getting in. And when we start thinking about it, well, that just seems logical. But I mean, obviously the traffic's going to be coming, there's nothing to be there to receive it. Just adding that additional layer of security in there. It's one of those things, you don't want someone to try and just sort of, if there's a small vulnerability in the system and it can come in through that route, if your traffic's not coming in at any given point in time, then you're just in a much stronger position. Okay, so just be very, very explicit about that. Okay, so what we'll do is we'll just highlight this, run that, and we can see that's gone off and created the rule for us. For example, as well, if we're running availability groups, then we also want to set up 5022, which is our default port, so that's what we're assuming. There's the target SQL server, so we're letting traffic coming in from that one for the synchronization traffic. Again, we're putting it in the SQL server group, and we just run that, and it will go off and create the rule for us. So now, if I come down here and do the get firewall rules, what we'll do is down at the bottom, there are 2 new ones. Awesome. Okay, there are 2 little rules down the bottom. Now, as I said, when you start using these, and if you put them into a specific group, this is where you get the firewall rules. So if I just highlight that one and run that portion of it, you'll see there that it's just pulled back those two rules for us. We can pipe those into set the firewall rule in order to enable it. Now you'll notice here that when I deployed these rules, I deployed them as disabled. Reason being is that you may have automated your installation of SQL Server, you just slotted this in, you've not actually commissioned it, you've not presented it out to the app teams, you've not given that sort of, okay, we're up and ready to go. So again, if you're not using it, don't turn it on. Same principle really, okay? It becomes very easy for us to, okay, well now we're commissioning, this is a step, I can do this because they're all grouped together. I may have 5, 10, potentially even 15 rules depending on the complexity of your environment. It becomes very easy for me to come in here and say, actually, boom, let's just do all of these at the same time. And there we go, just using the functionality within PowerShell. So, and again, when we start looking at these and saying, well, what does it look like? There we go, they're up and running. Those are our two rules. We're filtering by the group. Makes life a lot easier for us. Okay. So that's how we set up with Windows Firewall commandlets. Not horrifically complex, easier than it used to be, that's for certain. Now, come across when we look at using desired state configuration, there's a couple of prerequisites we need to do here. The assumption here is that we've got the networking DSC module down from the PowerShell gallery. That will need to be on the machine I'm defining the configuration on, where I'm setting it all up, or a build server. And it also needs to be on the target machine that we're going to be pushing this configuration to, or pulling the configuration down to, in order for it to be able to set the appropriate values. Now, I've already done this, saves me downloading it and setting the module up and everything like that. I've done it on my target machine as well. So we'll skip over that step and we'll dive straight into setting up the configuration. Now, as you can see here, we've got the firewall, SQL Server firewall configuration. Naming things is always the most difficult thing in IT, really, rather than anything else. But once we've got the configuration, in order to facilitate this for the particular systems we're looking at, then this is where we need to make sure we're importing that DSC resource to be able to use it, and it's coming in that particular module name. Now, you can import multiple DSC resources, so if you're using the SQL Server DSC resource to install SQL, you're using networking to set up the firewalls, you could be using certificate or computer management, any number of them, and they can all go into forming a larger configuration for the overall server in different areas. So SQL Server installation, SQL Server configuration, firewall configuration, certificate management, you name it. Okay. Now I'm being very explicit here. The node that I'm going to be configuring is SQL01. I can parameterize this, and then at runtime, when I'm essentially generating the MOF files, I could pass in some configuration data that has multiple servers, and it will spit out multiple configurations. But for the purpose of this demo, we're just going to be doing this very explicitly. I'm going to be creating one rule, which is allowing 1433 in. You can see there that I'm just suffixing it with the DSC. So that we can see when we look at them all together, we'll compare and contrast the ones we created with firewall, PowerShell versus the one that we're doing here. Now you'll notice that the configuration is by and large the same as the parameters I passed into the PowerShell commandlets. A couple of minor differences in the profile here is clearly a collection, as are the local ports we're listening on and the remote address, but we're still able to define it and bind it to a service. We've got all of the information in there as well. So if I just create this configuration into memory, what I can do then is I can call the configuration, and that will generate our MOF file, which is a managed object format, which is essentially a definition of what we want it to do. Okay, so that's going to create our SQL1.mof. Now what I can do here is push that configuration out. So essentially I'm saying in this directory, start the DSC configuration, push this out to the target servers. Now there's two modes that DSC can operate in. There is the push mode, which we're doing here, where I'm being very explicit and saying, right, I want you to push this configuration to that machine. Okay, which is great if you're doing it through things like Azure DevOps, for example, and you're getting the build agents to actually push those configurations for you. The other option is to use something called a pull server, where you can have an SMB server, or you can have a Internet Information Services IIS server configured, and you register the server with that centralized location, and you publish the configurations there, and they pull the appropriate ones down for them. Okay, for the purpose of this demo, we're just going to do a push. So, as before, you can see there that it's enabled by default. No, it's not. So we're pushing this one out. So we'll see this, and you'll see here that as it goes through, it gives us a verbose output, and we can see, okay, it's running a bunch of tests. Does this firewall rule exist? If it doesn't, then we create it, set the resources, there we go. So in not very many seconds at all, a couple, we've now got our firewall rule out there. So if we have a look at that one, we can see, yep, there's our DSC rule tacked on the end quite happily, looking the same as our other 1433 rule. Now, if I want to change that configuration, I want to set it to enabled, this is where we go. We come back to the configuration, we update this particular value, and you can see here ensuring that it's present. So it's exactly the same as the one above. So if I recompile this and generate some new MOF files, we'll do that one. And if we start that configuration again, you'll see here that it's going out, it's doing the various different tests, and here we go. Enabled property value false does not match desired state, which is true. So then it goes off and updates the firewall rule. Okay, so this is very, very sort of very useful if you want to define your configuration. If you've got drift, it will detect it for you and it can automatically remediate it. Saves you having to do a lot of that idempotence and that configuration in the scripts that you write yourself when it comes to the PowerShell side of things. So if we now look at the rules, if I come back, hit that one, you'll see there that now it's enabled. Okay, so that's been a very high level, quick look at managing the Windows Firewall with PowerShell DSC. So with that, we'll go back to the slide deck and have a quick summary. So that was our first demo, where we just had a quick look at PowerShell, see just what it can do to help make our lives a little bit easier when it comes to managing the Windows Firewall. So let's have a brief summary of the demo before we move on to the next section. Okay, so what we're looking at here is we looked at how to use essentially the built-in PowerShell commandlets to allow us to do things locally, and using the sim session we can do it remotely as well. What this means that we can look to try and do is we can use things like Azure DevOps, we can use Jenkins, we can use these other automation agents to actually go and run a lot of those scripts, so we can build those sort of wrappers around them, we can build those rule definitions that we need, and then we can push that out. One of the key things that we looked at there obviously was being able to sort of interact and do that, so we could potentially wrap those commandlets in. So for example, a for loop, out for each loop, whatever, and then do that to multiple servers. We can push all of that out. Another option that we've got is PowerShell DSC, and now this really gives us that capability if we use something like a pull server configuration, where we can enroll the target SQL servers into the pull servers and have them pull the information down every, say, 15 minutes, half an hour, whatever. They'll automatically look and do that sort of assessment. Is this compliant with the rule set that we've got? If it has drifted, do we want it to remediate it? And we can have that remediated automatically. What it also means, if we update that rule centrally, for example, then it can get pushed out. And depending on how you do the configuration, if there's global rules, for example, you can push them out, or you can do them system by system. One of the key things there as well, and this is one of the real benefits around using something like Windows Firewall, which is built in, and using those rules that we create, is that we can then use that integration with the Windows operating system. So as you saw there, what we did was we turned around and said, okay, if we're going to link these rules to the SQL Server service. Okay, what that means is that if the service isn't running, obviously no traffic's going to get in, irrespective of whatever. So if your server is down for whatever, for maintenance, it still means that the firewall is going to be there and it's going to be protecting your system. Okay, very, very important. So it pushes that information away for us. Now, whether that's desirable or not, that's up to you, but I mean, one of the things that it really does help with, especially is if you've got multiple instances of SQL Server on the same system, you can bind the rule set for each instance to the service. Okay, so you don't end up with that cross-contamination, which makes life a lot easier. But when you are thinking about using those as well, when you start thinking about the network layout, use secondary IP addresses and then have the listeners for those instances tied into those specific IP addresses rather than everything coming in on one, for example. So you start again being more verbose, you're being more explicit about those configurations that you're setting. Okay, so that was segmentation of our networks. Now we're going to start talking about traffic encryption. Okay, there's two ways of doing this. There's TLS encryption using the SQL Server capabilities which are built in. That's personally my preferred option because it's more within our own sort of destiny to control. It requires minimal integration, minimal work with the potentially server teams or other teams that are controlling things like certificate authorities and what have you. The other option is to use IPsec. This does typically need a lot more thought, a lot more design going into it, and working with the other infrastructure teams that you may be part of and collaborate with in order to do this. Okay, so in this sort of situation, what we're looking to try and achieve is how do we do this effectively? Okay, well, before we get there, the first thing we need to think about is which version of SQL Server supports which version of TLS. Okay, pretty much everything there will support TLS 1 and 1.1. Sorry, don't use those. Okay, they are weak, very easy to break, and nowhere near as secure as TLS 1.2. Okay, TLS 1.2 should be your benchmark. Okay, that is where you should be going from the outset. Now, as you can see from this table, all the way back to SQL 2008 can be implemented, even though 2008 R2 and 2008 are end of life. Okay, it is possible to deal with that if you've got some legacy systems in your environment. Coming up to 2012, 2014, and then 2016 and above, it's just natively built in as part of the RTM product. Okay, so go back, look at the versions of SQL Server you have within your organization, look at the patch levels you're on, and make sure you're in a position to support these. Likewise, when it comes to the operating systems, make sure your operating systems will support that. Like I say, by default, TLS 1.2 should be your go-to. Okay, there are going to be scenarios where you may need to integrate or work with legacy applications of one form or another, in which case you need to then look at either allowing it server-side, or if SQL Server is connecting almost to another system using linked servers or whatever, then don't enable it on the server side, but enable it on the client library side. Okay, so all of that's very, very usefully set out there, and you can, if you follow the link on the slide, TLS 1.2 support from Microsoft, then that'll take you there and give you a lot more information. Just to be aware as well that the table I'm showing you is for the cumulative update pathway, not the GDR pathway. Okay, again, the official documentation from Microsoft will have all of that for you. So, what does SQL Server TLS look like? Well, we have our SQL Server and we have multiple databases on it. Okay, we have our client users. They connect to their laptops, and some of them may connect directly to our SQL servers to run Management Studio, or they've got an application on their desktop that needs to connect directly to the databases, be it an Access front end for a SQL backend, or they've got a Windows Forms app or something like that where you're using native Windows authentication. The other opportunity that we have is also if we're using an application server, it's a web server or a standard app server or anything like that, or publishing it through a management system. Okay, those are our common pathways between the consumer of the data and where it's residing on our systems. So we're going to concentrate on the traffic that's going to go from either the application server or from the client to the database server. Okay, that's what we can control, that's what we can put in place and secure using TLS encryption and configuring that with SQL Server. Okay, now in order to make this work really well, we can, if we want to, use self-signed certificates from the servers, but what that means is that the chain of trust between the clients, in this case the app server or the laptop, for example, doesn't exist, and you then have to explicitly state that you're going to trust that certificate and you trust that server as an authority. Okay, that is an inherently less secure implementation than if you implement a certificate authority, so a full PKI infrastructure, okay, or where you're using a certificate authority that both the laptop and the app server potentially can verify the authenticity of those certificates. And what we do, the most secure solution here, is we essentially deploy a certificate to the SQL Server system, okay, put it in the certificate store, and then that's when we then register the thumbprint of that certificate with SQL Server and say, right, we want you to use TLS, or we're going to use encrypt network traffic. Now there's another option that you can go up to, which is to mandate it. So all traffic must be encrypted. There's a couple of different ways of looking at that one. If it's a brand new implementation, great, okay, well worth looking at. If you can do it from the outset, and that's what you're commissioning a system to do, you're in a much, much stronger position. Okay, if you've not got legacy to support, which may or may not manage or handle the encryption. Okay, if you're dealing with legacy environments, not worth doing. Okay, now like I said, just encrypt it and off you go. We've got a certificate there, we've got the certificate authority, so when the client, either the laptop or the app server, connects to that SQL Server instance, what it does is it then negotiates with the one that's calling it, and then that goes off, right, well, here's my certificate, and that goes, okay, well, do I trust this? That's where the certificate authority comes in. So the app server here will go and talk to the certificate authority and say, well, I've been given this information, okay, I trust you, is this what it says it is? They go, yep, that's fine, and you can start dealing with the encryption protocols and encrypting that traffic. What that means is then that the traffic between the two systems is secured, which means that if someone does sniff those packets, they're not going to see the queries going in, they're not going to see the data coming out, and that's the more important thing, okay? Because it is very, very easy using things like Wireshark to just pull that information down. If in a virtualized environment, it's very easy to redirect network traffic into a sinkhole server or something like that by duplicating it, and becomes a very, very easy way to extract information. So just bear that in mind. So this does sound a bit complex, but the reality is, beyond getting the certificate setup done, actually deploying it and enabling it on SQL servers is actually not as difficult as it may seem when you look at how to do it with things like PowerShell. So this is where we're going to start talking and have a quick look at our next demo, where we're going to actually configure SQL Server with TLS encryption, and we're going to use PowerShell to do this, which will make life a little bit easier. So let's have a look at the demo. So here we are with demo 2. We dive into ISE, and again we're going to use SQL 01. So what I'm going to do here is I'm just going to remote onto that machine, and for the purpose of this demo we're going to create a self-signed certificate. I know I said don't do it, don't for production, but for brevity we're going to crack on and do this here just to illustrate a point. Now the DNS name, this needs to contain the NetBIOS name and the FQDN, essentially the mechanisms by which we're going to connect to the target servers for the instance. So if you're using availability groups, then you need the FQDN and NetBIOS names of the listeners. If you're using failover cluster instances, you need the FQDN and NetBIOS names of the virtual network name for the FCI as well, because that way when we're coming in on those, basically that's what the certificate exchange systems say. Okay, well, yep, I recognize this certificate is basically saying this is a valid server that we're connecting to. Okay, it's going to drop it into our local certificate store on the machine, and then what we're going to do, in order to actually use the DBA tools functionality, we need to get the thumbprint of the certificate we just created. Okay, so if we grab this one here, okay, and we pop it in here, I just need to exit the session and come back to my local machine context. Now what I'm going to do here is use set DBA network certificate to basically tell the SQL Server instance on SQL 01 to use the certificate with this thumbprint for our TLS encryption. So ordinarily this would be what we're logging into the machine and doing with the configuration manager when we start looking at the protocol security. This is where we go in, and from that drop down you pick the certificate and what have you. So this is doing all this with PowerShell. So what this means is that it's very quick and easy for us to automate the delivery of certificates, but then also set them on the SQL Server services. In order for that to take effect, I need to restart the services. So again, we're just going to say, let's go and restart the engine, the agent for us, which is nice over on SQL 01. So again, DBA tools to the rescue, and we're up and running. So now what I'll do is I'll just connect, and I'll run this little one here and basically says, is my connection encrypted or not? Now if I do this, you'll see that it is not. The reason being is because we're not forcing encryption on connectivity, I've basically said connect and don't encrypt my traffic. So where you've got that sort of legacy environment that you're interacting with, this may be an option that you need to look at doing. So if it will negotiate up and say, okay, well I want to encrypt from a client side, I can say go and do it. We got an error. Why? Remember what I said about using self-signed certificates. Because the trust chain's not in place, I need to explicitly say trust the server certificate. Okay, so we run the same one again, and now we're up and encrypted. Now, as I said, if we're running a nice, clean environment, brand new kit, brand new app servers, brand new SQL servers, things like that, we're in a position where we can actually look to force and mandate TLS 1.2 and the encryption. So what we do is, again, we go off and we use DBA tools, enable DBA force network encryption. Okay, so again, this is what we would ordinarily log into the box to do, fire up the configuration manager and say, actually I'm going to go and tick that, well, use that drop down, I'm going to say yes, I want to force encryption for everything that's coming in on this one. Okay, and again with the configuration option that we're looking to make here, it's just taking a couple of moments, so we'll just wait for that one to wake up, and then in order, again, there we go. What we need to do is restart the services again, make sure that's going to take, so this is obviously going to take a bit of downtime, so it's not something we do in the middle of the day necessarily, but one of the things we do, we push this all out, do all the configuration with PowerShell. Service has been restarted, so if I come down and then run this again, you can see without forcing the or setting the encryption flags here on my connection, I'm automatically being encrypted. Okay, so we're in a much more secure scenario for where we need to be. So that was just a very, very quick look at how simple it can be to enable TLS encryption for our SQL Server instances. Obviously, there's a little bit of pre-work that you need to do in there and work and collaborate with some of your colleagues, but let's have a quick summary and we'll move on from there. So thank you very much. So that's our demo on how to enable TLS security with SQL Server. So let's have a quick summary of the TLS piece and then we'll move on. As I said before, for the most secure implementation, make sure you're using a certificate authority, PKI infrastructure, to essentially build that chain of trust between where you deploy the certificate and those that are actually basically need to authenticate that in order to do the negotiation. Okay. One of the key things we need to think about is certificate rotation processes. Okay. How long are we going to have certificates valid for? In the event a certificate is compromised, how do you look at basically setting it to be, how do you revoke it, how's it not trusted, how do you deploy new ones? As we saw there's a really useful DBA tools command that will allow us to very rapidly change that thumbprint, so if we get a new certificate onto the server we can flip it very quickly. Obviously we need to restart the services, so it is a disruptive process. Now as for the duration of certificates, it comes down to how many systems you've got, the frequency with which you need to change them. One thing I would try to definitely avoid is having a mass certificate rollout, because in that sort of situation you're in a position where you then obviously need to deploy and restart a large number of systems to be able to implement that TLS security. Ideally try to spread it out. I would typically go for let's say 12 months for a certificate lifespan, because that way it can be rotated, or you're going to rotate it once a year, spread those out so you're doing a few a month. That type of thing can make life a little bit easier. In certain scenarios you may want to go a little bit longer. I would try to avoid coming any sort of less than 12 months, just again simply because the overhead of rotating, deploying and then restarting the SQL Server systems, even though we should really be restarting them on a monthly basis when we do patching for the operating system, or when we apply cumulative updates or what have you for SQL Server systems. Okay, so we've got plenty of opportunity to restart systems, but it's just whether or not you want to add additional workload into those things. Okay, so we've spoken about network segmentation, we've spoken about TLS. Both of those are sort of very focused primarily on our sort of on-premises environments. So what about the cloud environments? Okay, are they radically different? Well, no, not really. Fundamentally, the principles still apply up in the cloud, whether you're running IaaS, whether you're running PaaS. Okay, when you start looking at what Microsoft are doing with the Azure platform, you can run SQL Server in VMs, you can run it in managed instance, you can run SQL Server at Azure SQL Database. You've still got TLS in place, so TLS 1.2, you've got that across the board, across all three of those offerings for SQL Server. Okay, so our traffic can be encrypted there, and it's often done by default. Now, when we start thinking about actually implementing network segmentation and the principles that we're looking at there, well, this is where, okay, you want to deploy to VNets, you want to make use of things like private link. This is where you want to be looking at service endpoints, putting it down onto the network segments, because what that means is when you define the VNet, the virtual network within Azure, you're then deploying and defining the subnets as well. And within those subnets, that's where you'll have the service endpoints, or you'll have your VMs. Then you've got network security groups, NSGs. Okay, that's essentially the best way to describe it is basically like a firewall, which is defining what traffic can basically transmit within that subnet, or into the subnet, or from the subnet. Okay, so again, it's rules based. You set those rules in a priority order, and they'll be evaluated in sequence. Okay, then you've also got, obviously, you've got virtual firewall appliances. You've got Azure Firewall built into VNets as well, if you need to present a public IP address element to allow things into the virtual network. If you're not running a hybrid scenario, for example, where you've got something like a site-to-site VPN, or whether or not you've got ExpressRoute or something like that in there. Again, you've got all of those, and that will apply for infrastructure as a service or platform as a service as well, because Microsoft's got a real drive to push those those capabilities onto VNets. When you look at what Azure SQL Database is and Managed Instance, both of those can operate in a scenario where they're on virtual networks, and that's where you can push the access through. That's where things like private endpoint and as well can be pushed into Azure SQL Database. So again, you're securing that traffic much more effectively. Okay. But when we start getting to the cloud, it becomes a lot more important to plan your IP subnets, because the way that you're going to segment your network is going to be slightly different. When you think about building an on-premises data center sort of focused environment, you've got core switching, you've got perimeter firewalls, you've got core firewalls. All of these will go into place, and then you'll be quite a static environment. Whereas when you move to the cloud, it's a less static environment. It's a lot more dynamic in nature. Okay, you're building and you're destroying infrastructure because that's the way you can do it in the cloud. It's very quick and easy to spin up new resources, new capabilities, and then throw them away in order to save money. Okay, in that sort of scenario, Microsoft obviously recommend, when you're using Azure, to use things like a hub and spoke architecture for your network. So essentially, you're peering network segments together, you're peering VNets together. And what that means is you need to be very aware of the IP addressing network ranges that you're using within the hub network and also within the spoke networks as well. Because you can end up with a scenario where you may end up with IP conflicts, which is not great, which will prevent that peering. So you do need to put a bit more thought into it. But again, it's very easy to automate, it's very easy to rebuild if you need to. Okay, but just make sure that when you do start thinking about doing network segmentation in the cloud, look at your subnetting and make sure it's going to scale to what you expect to be able to do. Are you going to have 10 to 15 development environments that are brought online and torn down as and when they're required by the development of the business for testing and developing capabilities, in addition to your production systems? How are you going to segment them? How are you going to isolate them? How are you going to sort of deal with all of that as well? Okay, and then make sure you're using the right features. There is so many different ways to achieve the same thing up in Microsoft Azure. Like I said, you've got things like web application firewalls, you've got virtual firewall appliances, you've got Azure Firewall. 3 different ways of doing the same, essentially the same objective. Okay, you've also then, when you get to using things like Azure SQL Database, you've got a huge capability there with firewalls in those virtual SQL servers and those databases as well, where you're limiting inbound traffic, outbound traffic, that type of thing. Okay, so just be very cognizant of there's so many different ways to do it. Look at what's going to be most appropriate for your situation. Don't just take something that someone wrote online or a standard architecture pattern and implement that, because it may not be right for your exact scenario. Everything is, fundamental principles will always apply, but you just need to make sure that you understand what your threat landscape looks like. What are you trying to protect your business from your customers from? Okay, those are the key things that will help make sure you pick the right feature, the right resources, the right services to be able to protect those environments effectively. Okay, so that's been the session today. We'll just start wrapping it up into a summary before we start having a sort of 15 minutes of Q&A. The most important thing to think about when it comes to the security side of things, as we discovered here, it's all about layers. Okay, complementary technology configurations. Really important to understand. So, as I said at the very beginning, if you're changing the SQL Server port, don't just change it to a different port for the whole network. It's about, okay, well, that's one layer of security, and that system will have a unique port for every single one. And we're going to hide the instances, but if we're going to hide the instances, we want to make sure that our naming conventions don't give the game away as to what we're looking at. Then you want to start thinking about segmentation and micro-segmentation, and then encrypting traffic as well. So add all of those layers together. Now, a lot of people will talk about the security onion and things like that, where they're saying it's all about these layers. I don't like that analogy, quite simply because when you think about an onion, essentially those layers are nice and solid and you can't get through them unless you cut the onion in half. Whereas the reality is the security layers that we will encounter in our day-to-day work, they're fundamentally Swiss cheese. There's going to be a fault at every single level. And the way that it works is that you take those different technologies and you layer them in such a way that the holes don't line up. Okay, that's the way to look at doing it. So it's about having multiple layers of that Swiss cheese in such a way, it can arrange in such a configuration that you can't see the bottom piece of bread. Okay, that's how you end up with a nice big cheese sandwich, which is essentially what security is. Okay. Likewise, be very explicit about what things can and cannot do. Okay. You're only letting in things that you know you can trust. Everything else outside of that explicit allow is denied. Okay, zero trust mindset. Okay, if I've not said that it's trusted, it is untrusted, and therefore we will not let it in. That's how you build a more secure environment. Okay. Likewise, when you're using things like on-premises for virtualization platforms, make sure you're using all three of the firewall profiles. Okay, because it's very easy to accidentally add a network adapter on the wrong network segment and things can get in. If you've got all of that turned on, I don't trust that my server team won't make a mistake, because that's how we fundamentally learn as people. Everybody makes a mistake in one form or another. It's about making sure that we've learned how to protect ourselves from the impact of those mistakes. And if you've got all the firewall profiles turned on and they're all explicitly denied apart from the domain one, which is what you know you're trusting and letting in certain scenarios, if someone does accidentally add a network adapter on the wrong network segment, you are protected. Okay, so just be very explicit about what things can do, okay, because that's what your security posture is. And with that, thank you very much for taking time to listen to my session. I'm going to be around for a few minutes doing live Q&A, so please feel free to come ask more questions. My contact details were there, I'll put them again in the chat, so that's not a problem. Just want to say a massive thanks to Microsoft, obviously the support they give the data platform community here in India. Really wish we could have been over there with you this year, but it is what it is. Fingers crossed for next year. And finally, obviously going to post a selfie with the DPS 2020 hashtag there. There's a chance to win some prizes. Feedback is another great way. Please, if you thought my session was great, tell me why. If you thought there's areas I can improve, let me know. That'd be fantastic. And then obviously the sponsored exhibitors within the platform, go and have a chat with them. There's a plethora of great prizes there. Thanks to the team for putting the whole event on. And check out the team on Twitter. So with that, chat to you in a second.